Hey guys, so in this question, we're asked to describe the mechanism of Teflon formation, which goes through a radical addition polymerization reaction. So there are three steps in that kind of reaction. We have initiation, propagation, and termination. So starting off with initiation, the first thing that happens is we have a radical. Let's just call this R. So a radical is any molecule or ion that has a free electron like that. And our radical is going to be reacting with our molecule or monomer. So that's this compound right here, which is called tetrafluoroethylene. So we have 4 fluorine groups attached to this 2-carbon chain that has a double bond to it. So whenever we have a radical with 1 electron, this is going to try to bond to this carbon right here and make it have a radical itself. So when we have just 1 electron moving, we use fish hooks, which are half arrowheads to denote the movement of 1 electron. So when we do that, this carbon, we want to fill up its octet. So to do that, we're going to take 1 electron from this bond and place it at that electron. And since we do that, this carbon right here is going to become a radical itself when we add 1 other electron, making up this double bond to this carbon right here. So when we do that, we end up with this compound right here. So we have our ethane chain. Our radical is now bonded to that carbon along with our fluorines. And our fluorine now, our carbon that has these 2 fluorines now has a radical on it. So that's our initiation step to form this activated monomer with this activation site or reactive site. So now we can go on to propagation, so the formation of the rest of our chain. So starting off with the activated monomer, this radical now, since we have this lone pair of electron, is going to attack our monomers, so our tetrafluoroethylene groups. So it's going to do basically the same thing. So our radical is going to bond to this carbon right here. So that's going to cause this double bond to break, where 1 of our electrons is going to fill up that octet to that carbon, and the other electron is going to form a radical at this carbon. So we now have a 2-carbon chain. So let's just, or a 4-carbon chain. So let's draw that. So 1, 2, 3, 4. So we have our radical at our end, 2 fluorine groups here, 2 fluorine groups here. And this carbon right here has a radical. So this propagation reaction goes until the chain is long enough to what we desire it to be. And once we reach a specific length, it will terminate. So in our termination step, let's start off with our 4-carbon chain. So we have our radical and 2 fluorines. And this is going to form a bond between 2 radicals. So the radical that we started off with in our initiation step is going to form a bond with the radical from our propagation step. So when we do that, we're left with our Teflon polymer, which is now stable since we don't have those radicals attached to them anymore. So that is our mechanism for Teflon formation.